Hello everyone, this is the Chinese Mitten Crabs aquaponics project, and today we're going to talk about the BBC Microbit. Programmable physical objects refer to any physical objects, usually electronic devices, that allow people to design their programs to run on the objects. There are many examples of programmable physical objects, for example, robots, autonomous cars, smart home devices with embedded systems, etc. Today, we're going to study how to program a physical object by using a single board microcontroller. Traditionally, the input-process-output of a typical personal computer involves a lot of components: keyboards, mouse, and microphones for input devices, motherboard, CPU, RAM for system units, and monitor, printer, and speakers for output devices. Furthermore, for the system to work, they often require secondary storage, such as hard disk, USB flash drive, etc. A single board microcontroller, for example, the Microbit we're going to talk about today, also has input, process, output. However, there are a variety of inputs and output devices, but the single board microcontroller can include both the system unit and its secondary storage unit on the same board, or the CPU, RAM, and flash memory are all on the same board. The BBC Microbit is an example of a single board microcontroller. It is designed for computer education. Here, we can see various features of a microbit. Every microbit has 25 individually programmable LEDs, 2 programmable buttons, physical connection pins, light and temperature sensors, motion sensors, compass, wireless communication via radio and Bluetooth, and a USB interface. The 25 individually programmable LEDs is in an array of 5 × 5. The LED screen can be used to display output in the form of numbers, text, images, and animations. Each microbit also provides 25 external connections, also known as pins, on the edge connector. Pins P0 to P16 can serve general input and output purposes, so they are also known as general purpose input and output pins, or simply known as GPIO pins. Amongst all the pins, there are 5 large pins labeled 0, 1, 2, 3 volts, and ground on the edge for connecting to P0, P1, P2, 3 volt supply, and the ground respectively. These 5 pins also have large holes for attaching crocodile clips to create electric circuits with other components. After talking about the basic features of the microbit, let's talk about how we can code the microbit. There are several ways to code the microbit, including JavaScript, Microsoft Touch Editor, Python, and Microsoft Block Editor. Out of all the editors, we will make use of the Microsoft Make Code Editor to code the microbit. So first of all, you should go to the Microbit website to code the microbit. The Microbit website can be accessed by microbit.org/code. To start coding, click on the Make Code Editor tab. On this page, we can do a lot of things. But first, let's start a new project. We can click on the New Project tab and start a new project. For example, Chinese Mitten Crabs aquaponics project. Then you will see this page. On this page, there are various tabs that you can pull out. And when you drop the tabs into the main page, it can help you code. For example, I would like to code a heart image on the LED of Microbit. I can drag and drop a heart image onto the code, just like this, and then the code is ready to be uploaded onto the Microbit. First, you download the code by pressing the left bottom button download. The code will be converted into a .hex file or .hex file. Then you connect the Microbit to a computer via a USB cable, and you can drag and drop the .hex file onto the Microbit. If you can successfully transfer the .hex file onto the Microbit will run your code.
Now, let's do something more about LEDs. Alright, so let's say I want to have a flashing LED in the middle of this board. We can take this out, put it here, and put it on start. And then there will be a long light here. So it's still not flashing. So we can add some other things. For example, we can add pause, and then put it here. And we copy and paste. Like that. And then pause. Like that. And play it. Something like this. But that's very strange, because you see that if I keep on doing this, the thing will be very long, which isn't desirable. So we can move on to the repeat function instead, or the forever. So we can move this to here, delete all the things we don't want. So it will light up, wait for 10 milliseconds, and then switch off, wait for 10 milliseconds, and whoop, go back, light up, and so on and so forth. Something like this. But that's not good enough, because we have to control everything by just clicking. It's not very scientific, is it? So we can use the click LED, and we can use plot instead. But on plot, X, Y, it's rather strange. What does X, Y mean? In this case, we can look at this diagram. As you can see from the top left-hand corner, it's 0, 0. X is a horizontal and Y is the vertical. So the number after next is 1, 1, 0. Because in computer science, we always start from 0. And therefore it's 1, 0, 2, 0, 3, 0, 4, 0. And down is 0, 1, because this is still the 0x. So 0, 1, 0, 2, 0, 3, 0, 4. And therefore we'll have a grid of something like this. Now coming back. So if I want the middle one, which is 0, 1, 2, and 0, 1, 2, so this one is 2, 2. So if we type 2, 2, and then put here, then remove this, then we will have a flashing, we will have a light, but not yet flashing because it will be long on. So therefore, let's go back to LED, and we can unplot it. So just the same light, switch it off, put it back in, and if we run this, aha, we can see it's flashing. We can see it's flashing. So we can change the time, so maybe 1 second, and 1 second, and play it. Then it will flash at every second. And therefore, we have a flashing light. And we also understood the coordinates of the LEDs on the microbit. Alright, after learning how to have a flashing light in the middle with this plot, then let's try how can I move a light from the left hand side all the way to the left hand side while flashing. Well, what we can do is plot 0, 2, and then switch off 0, 2, then switch off, then have 1, 2, and then switch off 1, 2, so on and so forth, like this one here. So 0, 2, and then 0, 2, switch off 0, 2, then have 1, 2, and then switch off 1, 2, and 2, 2, switch on 2. Something like this. So if we do that, you will have something like this. So it flashes from left to right. Very good. However, this is a bit too slow, and there's so many statements here. It's not that good. So we can have other things. For example, first we can have loops. So we can insert a loop here, plot my plot here, like that. But then I want this to be changing, right? You want the x value to be changing. So you can invert a variable like this. So let's make a new variable called x, or x is already here. So you can have x, and then you can unplot x as well, and then remove all this. And if we remove all this, like that, x will be changing from 0, 1, 2, 3, 4, and every second. So when we have this, and we add the x variable into the index like that, then play it, it should work. So therefore, the x is changing for us, and therefore we don't have to type such a long statement.
Let's talk about the relationship between Microbit and Chinese Mitten Crabs aquaponics project. Similar to Arduino, Microbit is also a single board microcontroller. Therefore, we can use a microbit to detect the environment variables and then send signals to output devices. For example, Microbit has a built-in temperature sensor. We can program the microbit to turn on a fan if the room temperature turns too hot. This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. We'll see you next time. Bye bye.